In this video, I want to review the two types of confidence intervals we've made, and then talking about solving for a sample size when dealing with sample means. So in a survey of 1,300 people, 29% said they would live in a haunted house if it meant they would have more bedrooms than their current home has. And that really is a true survey I found online. Create a 98% confidence. Now the reason I put that in red is I just feel like we probably spent enough time here doing state plan, do, conclude with some of the writing. So this is the state part of it, okay? Plan. Well, it's a proportion problem, so we're going to make a proportion interval. So the first thing we need to do is say is 1,300 less than or equal to 1/10 all people, I guess, with homes, or that, you know. And yes, it is. And then 1,300 multiplied by 0.29 and 1,300 multiplied by 1 minus 0.29. This is 377. This is 923. Both of those numbers are larger than 10. We hope we have a simple random sample. And we're going to proceed. So, do. Let me do this on the calculator. Okay, so I've dropped the calculator captures in here. Remember, you go to the stat test menu. Letter A is one proportion interval. It still is a Z. You know, T is for sample means. Z is still going to be what we use for proportion. And the reason we can use Z here is because we've added this condition that the sample means don't have, this NP times N times 1 minus P. And then when you hit calculate, here is our interval. And of course, you see it gives you a P hat. Make sure you notice that X has to be the number that said they would do it. You can't type in 0.29 there, or you'll get an error message. So now let's do our conclude. We are 98% confident that the interval from 0.26 to 0.32 captures the proportion of people that would live in a haunted house if it meant they got more bedrooms. All right, let's move on to a different example. In a sample of 50 married men, finds that the average age in which they got married was 29.1 with a standard deviation of 3.2. All right, so again, I felt like we probably had enough practice. So this is our state, our plan. We're going to make a T interval. Okay, we hope we have a simple random sample. Of course, 50 is less than or equal to 1/10 all married men. And 50 is big enough. It's bigger than 30, so we can use the central limit theorem. Remember, if it's not larger than 30, we have to know some more information. We have to know something about the parent population, like was it normal? If we haven't been given that information, we've been given like just raw data points. We have to make a graph, typically a modified box plot, in order to check the shape and that there aren't any outliers. Okay, but here we did have a large enough sample size. Okay, do. All right, here are my screen grabs from the calculator. So remember, you are building a T interval because, again, these numbers, the mean and deviation, are both from a sample, so we shouldn't be using Z. We put in our stats. There they are. I build a 90% interval. Here it is. So now I can conclude. We are 90% confident that the interval from 28.3 to 29.9 captures the average age at which men get married. Okay, I want to add one last thing to this problem as kind of a discussion point. So I want to know, if I wanted the margin of error to be no more than 0.25, how many men should be in my sample? So I just want to point out right now, with kind of some approximating, the mean was 29.1. Here are our endpoint. So the margin of error was approximately 0.76, I suppose. So really, I almost want to cut that. I want it to be a third as large. I want my sample size to be approximately a third as large as it is. So if you remember our formula for confidence intervals, and you really do need the formula for this, it's always the statistic or the point estimator plus or minus the critical value multiplied by the standard. Now we start calling it error because it's we begin, put this all-encompassing term here. So the standard deviation of a statistic is, we call it the standard error. The point estimate has nothing to do with margin of error. This is the margin of error. I want this to be equal to 0.25. Well, the standard error, we're talking about, again, about a sample mean. We're solving for sample size. So this is going to be 3.2 divided by the square root of n. But the critical value gets a little tricky here because when we think about t, we really need a sample size in order to know the degrees of freedom. And this is too many things working at once. We have to solve for this n. We can't also need to solve for it to get a t. So in fact, we go back at this point to z star. Okay, for problems like this, we're going to use z star. So let's look up the z star that goes with 90%. So you'll remember that we go to our table B, this distribution, the t distribution, go down to 90% down here. The z is 1.645. So I'm going to get this out of my way, put that up there. It is 1.645. And I need this to be equal to 0.25. Here's what I would do first. I would multiply these two numbers, 1.645 multiplied by 3.2. I get 5.264 over the square root of n equals 0.25. Multiply both sides by the square root of n, and then divide both sides by 0.25. So now you have 5.264 over 0.25 equals the square root of n. Of course, you will square both sides. And remember also that you get here an answer of 443.35, but we always round up because to go down would not ensure the margin of error we want. So always round to the always round up regardless of the decimal. So 444 people, or men, I guess. Now, I wanted to mention a little bit more about some algebra here, and that is the fact that we essentially wanted to cut our error by, divide it by 3. I want you to notice that we used to have 50 people. We have almost 9 times as many more now. That is a function of the fact that we use the square root of n. When I say I want to cut it into a third of what it was, a third of what it was, that means I need to multiply my sample size by 9. If I said, you know what, I have a margin of error of 2%, but I want 1%, I want to cut my margin of error in half, then I would need to quadruple my sample size. Whatever you want to do to your margin of error, you have to do the squaring of it to the sample size. So very often, something like the Gallup poll, the National Gallup poll that's reports a margin of error of 3%, people will say, well, why wouldn't you just ask more people? Well, if they're already asking 1,500, is it really worth asking 6,000 to cut their sample size in half? Is it really worth quadrupling a sample size to cut your margin of error in half? Oftentimes it's not. So that's why we kind of make a reasonable approximation based on the easy sample size to get.